So yeah, I'm really excited to be here, especially because I had to do nothing to prepare for this amazing event except prepare for the talk. Thank you, Jed and Louisa and Michelle and everybody else who worked on it. The last couple of cloud native Geo days ended up being a whole bunch of work for mostly me to organize. So it's been awesome to see, yeah, just be here as a participant. So I think everybody here watching live is a cloud native Geo Forum member. So thank you. And if you're watching this as a recording, I do encourage you to join the Cloud Native Geo Forum. Your member fees help the Cloud Native Geo adoption. So I'm normally with Planet. Today I'm here on behalf of the Tailored Geospatial Engine, who I've been working with on these projects. Thanks, Kushing. That's like a build. I did not realize. So yeah, here to talk about these two projects I've been focused on with my sort of open community time the past few months, 9 months. So fiboa is a specification inspired by the STAC to describe field boundaries. And then fields of the world is labeled training data sets that sort of gathered and harmonized a whole bunch of available open data sets to spur development about ML models. So the reason both have happened is because of the Tailored Geospatial Engine, or TGE for short. So it's a sister organization to the Tailored Geospatial Institute, which probably more people have heard of. TGE is a sort of little nonprofit focused on commercialization of innovative research from the Institute. And one of the main activities is what we call innovation bridge initiatives. So the goal is to bring together academics, industry, NGOs, governments to work collaboratively and learn from one another. The focus of these initiatives is building foundations for global data sets, exploring the potential of AI and ML plus satellite imagery plus cloud native geospatial standards. So the first initiative was inspired in part by Jen Marcus, who's the executive director of TGE, seeing Dr. Hannah Kerner give a talk where she was riffing about the lack of things like ImageNet and ResNet for geospatial projects, and particularly for field boundaries. So Hannah and the lab had sort of started on this. TGE really aimed to accelerate that start with a larger group, bringing in Nathan Jacobs, who's part of TGI, and his lab, and organized a kickoff in the spring with numerous groups interested in field boundaries across companies, governments, NGOs, and academia. I'll skip over the details of how it worked, but I wanted to highlight some of the things that have been achieved in a mere 9 months with pretty minimal funding overall. So the first thing we shipped was the fiboa spec. Big thanks to Matthias Moore, who many of you know from STAC and beyond for this. He led all the development of the spec and the tools. And the core idea was to enable interoperability of field boundaries and related agricultural and supply chain information. So the spec's really inspired by the lessons we learned from STAC, many of these the hard way, particularly the idea of keeping the core very, very small and making it easy to create extensions and kind of have this marketplace of extensions, but not have to change the core and move the core. We haven't yet made as much progress on the extensions as I'd have liked, and I think in part that's due to lack of good open data sets that represent more than just the field boundaries, but we've had a great group joining, and I'm optimistic we'll continue to make good progress here. We also really decided to embrace GeoParquet. It and GeoJSON are the two sort of fully supported formats, and then have tools to translate them, validate them. And so unlike STAC, the geometry and the attributes, they are the data. They're not a reference to some other data. There's no assets. So we wanted a kind of core binary format where you'd easily be able to share a whole data set. So that's why GeoParquet is sort of, I would consider GeoJSON kind of reference, but most data produced is in GeoParquet. And then we often convert to PM tiles from there. So we've invested in tooling to make it easy to work with the data. You can describe the data. There's this fiboa command line tool, convert between GeoJSON and GeoParquet, convert non-fiboa data into the standard. And then just like STAC tools, we've made it very easy to create a converter and invested in making converters for a number of different sources of data. Matthias just this morning, I think, or maybe it was yesterday, yeah, I think it was today, released version 0.8, and it added 8 more converters that were after this particular screenshot. And it's really easy to make a converter. I sort of did one in my evening last night. I finished one off, but the idea is make it super easy to get all this diverse agriculture data into this common format and then be able to do stuff with it, enhance it, use it more interoperably, et cetera. So far we've converted about 30 million fields from a number of countries. And yeah, I've really made it a priority not just to make the converters, but convert the data, start to show the value. And yeah, the cool thing is, we made many of these converters. Some of those you see on the map were others. Some of them were AI ML generated. And then there's a few organizations that I think are going to bring much bigger data sets into fiboa before too long. So that'd be super cool to see. And then, yeah, I've personally learned that agriculture data models are a whole lot more complex than I was imagining. Deep knowledge in that domain. But I really hope that our extensions are flexible enough to handle these more involved agriculture data, and that we can improve to handle that. But we've made a decision to focus for now on the sort of AI, ML related use cases and the kind of reporting use cases. So generating field boundaries and related insights from space, and thinking of fiboa as kind of an interchange format, not really the format that you'd base your core system on, because there's a whole lot of complexities of farm management data. So one thing we wanted to get right was to be sure that one core property was the way the field boundary was created. So the main thing we want to know is if field boundaries are automatically created with AI/ML, so that other models know that I should not include this, generated data as my training data. So our hope is that in the future, there'll be open published data by farmers, by NGOs, by governments as fiboa that can be easily used as training data, since kind of all the right metadata is there. You know how it was gathered, you know when it was gathered. So that then segues to the other major project that's resulted from the TG Innovation Bridge initiative, Fields of the World. And the idea was not just wait for people to make training data available as fiboa. Instead, we worked to make this comprehensive benchmark data set designed to enhance the development of ML models for instance segmentation of agricultural field boundaries. Yeah, you can go to the website. There's a blog post that we just put out too. I'm sure Matthias or Kishin can put the link to that in there too. Thanks for helping. And yeah, it gives a good overview, and this will be a quick overview. So the FTW dataset, Fields of the World, FTW as we call it, has over 1.6 million field boundaries covering diverse agricultural landscapes across 24 countries, 4 continents. And this diversity of coverage allows the development of AI models that can generalize to different agricultural practices and field types. There's a number of data sets that, yeah, people have done to make ML models, but they're not that diverse. So yeah, the model may work in a country or a type of agriculture, but doesn't necessarily work globally. And we really want to see models that can be truly global. So first, you need a training data set that's global. So Hannah Kern and her lab had been working on aggregating and harmonizing open field boundary data, and then TG accelerated by bringing Nathan Jacobs' lab. Caleb Robinson from Microsoft AI for Good has been another major force in this. Yeah, has done a whole bunch of great work helping on the research and then generating models and all of that. And then me and Matthias Moore helped out on the software tooling, mostly Matthias. And then Source Cooperative helped with kind of the hosting and cloud native geo support. And then Radiant Earth has been a supporter throughout. So it's published as an academic paper, but TGE was kind of key to bring more resources to make it more than a paper at the start of a true ecosystem. So the data is all available on Source Cooperative. Every data set has a fiboa converter, and each country has a GeoParquet from that conversion for the boundaries. If it was a kind of trained data or a data set that was made for ML training, usually that's translated directly. If it's like a whole country that we converted, then the FTW will be the kind of subsets that's used in the FTW data set. So and then, there's a PM tiles for the whole data set that powers the maps you saw earlier. And then these, GeoParquet could easily be combined with any satellite imagery to create training data. But the FTW team went further to make this more accessible to ML researchers who kind of don't have geospatial experience, aren't really comfortable adding in the satellite imagery. And so they generated the rasters for instance and semantic segmentation masks, and then paired those with the right Sentinel-2, multi-date, multispectral. So you can do kind of temporal spectral analysis, but it's all kind of ready package for an ML researcher to not, to use in their tools as opposed to learning all about our geospatial world. And this to me is really important. I think too often we expect people that are new to geospatial to understand like a whole lot about our file formats and the quirks and projections. So I've long thought we need to meet people not just halfway, but more than halfway. And in this case, really let them focus on model training instead of, formatting files and figuring out geospatial. Let them get the win of training the model, working with it, do what they do best, which is the model training, and not the geospatial. And then we also wanted to make models much more accessible to geospatial people. So the FTW team did an amazing job making it easy for anyone to train their model, train your own model. So you can download any subset of data, even add your own data, tweak the model parameters, and experiment. And yeah, I followed the AI/ML geospatial progress for a while, but this is actually the first time I trained my own model. Super cool to just be able to do that and kind of have that. So yeah, you too can easily go through these steps and create a model. And then we also wanted to make models much more accessible to geospatial people. So not everyone wants to train their own model, so you can easily just download one of the FTW baseline models. These are created to define kind of like a baseline for metrics. They're not necessarily meant to be the best possible model, but to spur others to create even more performant models. But they're trained on the full data set and they often work pretty well. So yeah, made it easy to run a model for any area of Earth with a set of command line tools. Right now, you got to select two Sentinel-2 STAC scenes, kind of find the area you care about and put that in. And then this is a little example of command line calls to download images, run inference, and polygonize into fiboa output. So the download command uses ODC STAC to create the right input for the model inference. It's an 8-band image with 4 bands each for the 2 time steps. And you can include a bounding box to have a subset. I'm going to use it here. So the process can be a minute instead of like 10 minutes to download all the data. And then, yeah, we should get a little QGIS view that shows the results of the download. And you can adjust the bands to get different views of the data. And then, it's a little catch up, but inference runs pretty fast. So it generates a raster image with 3 classes for fields, boundaries, and kind of blank. And then there's the 2 classes that do just fields. The boundaries, they're not great. This is the 2 time steps. Boundaries aren't great in a lot of areas right now, but for vectorization, it kind of doesn't really matter. So yeah, we can run inference. I know we ran inference right there. So yeah, my screen's covered. So 6 seconds, 7 seconds, and then you can polygonize into fiboa and GeoParquet. And then we also support GeoJSON, flat GeoBuff, and GeoPackage output. And then it does simplification. You can control that. So yeah, here you can see the inference, the raster, and then the polygons that were made from that. And yeah, the polygonization algorithm is pretty naive, but we're hoping to kind of advance that and do more cool stuff with it. So yeah, you might have noticed that you could select a CC BY model. Each data set has a particular license, and that's so you can train a model and use exactly the license terms that work for you. So we want to enable companies that can use kind of more liberally licensed stuff as well as researchers. And yeah, you can see the CC BY model actually performs pretty well in many situations. This picture shows the metrics you can generate. We aim to kind of have these objective metrics. So there's test, train, validation splits of the data, and it can you can use these metrics against models that weren't even made from this data. We kind of want it to be a way to measure performance and get all that you can to get all the best models. So one thing I hope everyone takes away from this is that we've designed all these pieces to maximize collaboration, letting people use or contribute just the bits that are most relevant to them without having to sort of buy into a big vision. We're excited for anyone is all in, but the nature of building kind of truly global data sets is that no one organization or individual is going to have all the skills needed. So our goal is to design these kind of architectures of participation to let everyone be locally selfish, but globally collaborative. And we'd love help. Whole project's done on truly a shoestring budget, but we've accomplished a whole lot by tapping into passionate people who've been aligning how they work to collaborate with others. This is just the start. There's tons to do to make this vision reality. So yeah, we're excited by how many people have already started to contribute, and we'd love you to join us. I have much less time than I was talking. I was thinking, Jed and Michelle, do you want me to go more into cloud native geo stuff or wrap it up there?
I mean, you can go. Since it's kind of the more breakout session now, I say just keep going. And
Okay,
people
cool.
want to switch something else, they can. If people want to stick around and listen, then go for it.
Sounds good. So yeah, I thought I'd have some time left, but yeah, Michelle is letting me go over. So I wanted to riff a bit about where I hope to see CNG headed and where I'll be spending my time. So yeah, Jed originally lined me up to do the keynote, but I realized a couple weeks ago, I was like, I have no time to make like a good talk that I would feel would be worthy of that. So huge thanks to Javi for stepping in. This talk was a lot easier to put together because I've been working on and writing about these two projects. But yeah, I kind of want to share a few thoughts that I would have included in a headline talk. So last year I gave a talk at FOSS4G North America that proposed working towards kind of a cloud native spatial data infrastructure. And this is one of the favorite talks I've given. Do check it out if you're, did not before and want a deeper dive into these things. But I had this slide in my talk, and if we're easy to modify, like using ChatGPT, I tried, I'd add models as kind of like a fourth circle. And in geospatial, it's felt like since I've started a long time ago, we've had kind of separate communities, one for standards, with OGC, one for software with OSGeo, one for data with OpenStreetMap. But we sort of all know that the magic comes when everything comes together, when you have standards and data and software. So I've increasingly been thinking about how we build ecosystems that are really about kind of all the parts. With STAC, we started with a standard, but we did know that adoption was going to depend on sufficient valuable data in the format. So we worked to get as many early implementations of the big data sets into STAC as we could. But I think data really needs to kind of become the top focus with the standard software models all directly supporting it. So I'm most interested in kind of truly global data sets. How do we combine AI and the massive amounts of EO data with the right software standards and kind of high quality ground truth data to fully map the globe? And not just as private data like Google has, but a true commons that many actors contribute to, and many, many more get value from. So yeah, Overture has been leading the way here. So awesome that this came into existence. Starting with OpenStreetMap, aggregating the best computer vision generated data, releasing it as GeoParquet, contributing to the GeoParquet standard. Jake from Overture was really the driving force behind version 1.1 and getting it more cloud native. And then, yeah, they've also built kind of a whole set of tools to make use of this data and encourage that ecosystem. The most interesting part of the work that they've done to me is actually schemas. And so they made similar choices as we did with fiboa, kind of representing the schema in GeoJSON, JSON schema, and then the actual data in GeoParquet. They've done really great work on IDs. We've done less of that in fiboa. And they're thinking about how that core data model can be extended with other attribute information. I think we went a bit further with the extension mechanism and yeah, had some great discussions with them. But I see these like huge value in defining reusable attributes for common types of geometries. And so like the potential goes far beyond just the Overture data set per se. So this was an exercise I did a few months ago where I tried to download the San Francisco building data set and query it with LLMs. You know, LLMs can talk to data, and the LLM made reasonable guesses to like calculate the height. How many buildings in San Francisco are over 200 feet tall? But it picked the wrong attribute. You know, it like wasn't right. There were like 10 different attributes that had all these obscure names. So my hope is that like Overture attributes names become widely adopted, and that a data set like this would have the same height attribute and would know that it's the Overture schema. So any data set you download from a city or county office would instantly be queryable by height with any LLM, that you'd just be easy to understand. You know, that height's in meters and not feet. And yeah, just work with it. Because you just have to teach the LLM about the standard as opposed to trying to teach it about every single data set. So yeah, if the city of San Francisco posts their high quality LiDAR measured buildings with the Overture height attribute, that in turn could be easily turned into training data to improve the AI ML algorithms that are generating building and footprints and height information. And then that could be used to train other building attributes, building material for risk assessment, you know, more height information, other air conditioners on the outside. And if it works best, if there's lots of software tools that make it easy to follow the standard. So like we need that tooling. So my hope is we start to see similar feedback loops on all types of global data sets, and also build up kind of more valuable attributes on foundational features like buildings, forest, fields, where we get training data and tooling so that people can publish it, that in turn makes those models and algorithms better, that in turn makes more and more useful global data. And yeah, that to me is the potential of cloud native geo, not just to make some formats that make it cheaper and easier to distribute data, but I think that's a worthy goal, but to bring together the right communities and collaborations to build truly global data sets to understand our world together. And I think that's it. Yes, thank you.